All right. This is the CSCE247 Lumberjacks Criminal Database Software presentation. I want to get started first off by going straight into the scenarios. So we'll go ahead and start off with scenario 1. So go ahead and get everything running. Then we're going to log in with an existing account. Alright, and then we're going to go through the scenario. So let's go ahead and do this. Alright, just about done with this one. And now we're going to start adding in the victim, which is Henry Clemont. Alright, going to go ahead and put in his address, which is 123 Gervais Street. And his statement. So for him, he was at the front of the store. Alright, that's it for Henry. And then we'll create the new crime. Alright. So we're going to go back, and now we're going to start off with scenario 2. So since we're already logged in, we'll go ahead and do this. So we're going to go into search, and we're going to start off searching for someone with a dove tattoo. So as you can see, we get two 44-year-old female and a 21-year-old male. Both, the only thing in common they really have is a dove tattoo, but that's not what we want. So we are going to go back, and then go back into search, and now we're going to look for some different criteria. So we want someone in their 30s, someone with black hair, and we want them to be 6'2". We're going to go ahead and search for them. So we get 3 people. All of them share those former traits in common. So we're going to go ahead and print them out to a file. And as you can see right here, all 3 of them, they have their information printed out to a file right here, and it includes everything that was just shown in the program. So we're going to delete this file just that way the next scenario doesn't interrupt it or make anything too crazy with it. So what we're going to do is go ahead and end the program there, clear, and then we're going to restart it. So that way we can log in again. We could log in, but it's easier to go do it this way. Alright, so I'm going to log back in. Alright. Now we're going to search for a person with a specific case ID. That's going to be C10105. And we're going to search for that report. And what happens is that search immediately is output to a text file. And as you can see right here, this stores all the information about the crime that we're able to pull in from the file itself. So that's it for the scenarios. I think we're going to go ahead and go back to my team members now and check out the UML. So I believe that's Blake up first.
Making sure y'all can hear me.
Yep.
And then should be able to just share this. Hopefully my internet holds out, but okay. So y'all can see my screen all right?
Yep.
Okay. So this is our entire UML. It's quite behemoth. But what we'll focus on first is sort of this left half, which is what I was using to create the UMI. Now the UMI functions using the UI, this screen superclass, and also this telephone class. These three classes give a lot of functionality to the UI. And so I'll start by showing off the UI itself in code form, if I can get to it. There it is. Now the UI itself is actually pretty small. It just has this display method, which takes in a screen object, the start screen object to be specific,
You're good. I'm just
and
recording
displays it,
presentation.
grabs
So
input,
I just can't be
and gets the
talking.
next screen. And right
Yeah.
up here, I added something into CLS, the terminal. Basically, it just adds a bunch of print lines to segment everything out. The main function is basically just while this displays. If a screen is ever returned as null, then the program stops. And then that's how the UI functions. It connects to several other things, mainly the UI constants. This is where a lot of the screen data is going to be stored for a lot of different screens, such as the create account screen, login screen, and they all have a very reduced look to them. And the reason is because I make use of two screens to get a lot of the basic stuff out of the way. That would be an editor screen and a transition screen. And what these allow me to do is by changing just a few strings that I input as parameters, it wildly creates differences. So for instance, I believe if we go here, just to show off on the program real quick, for the welcome screen, for example, exit, login, create account, if we go to UI constants, we can see that on the welcome screen, all I needed to put in was exit, login, create account, and these commands in string form right here. Now these commands get linked to this telephone class right here. And so what happens is when we call next, when we try to go to a next screen, for example, in trans screen, what happens right here is telephone.call. Telephone acts as its name, a telephone, to call different methods in the program using the string that's input. So when we go look at telephone, we see that it holds different groupings, fact calls and screen calls, and breaks apart the command put in and calls the method in the given class. So for example, when we call login on the program, what's really happening is S login is being sent to the telephone, which is in screen calls, which is the S part. So in screen calls, it holds all these commands via easy to 8. Here it is. For example, login links a function reference back to UI constants login screen, which then creates the information for login screen to be created and then displayed to the screen. And that's mainly how our UI sort of functions on that end. A lot of the other classes just deal with sub information, entering stuff in, getting it back out, and stuff like that. But I believe that's all I need to talk about for this. I guess the only important thing to add is that all of these screens extend the base abstract class screen, which just has next and display. So, but beyond that, that's it for me.
Okay. So here is the facade, connects to the UI. Basically, I have it set to where it only connects to evidence and user and crime. However, it connects to others such as like officer, POI, victim, and stuff. The only reason I didn't update it in the UI is because it would be a giant mess. Because the facade basically makes it like the mess compiled instead of having like a spider web of connections. But basically, it allows you to find a person, add a person, edit a person, all the way through like officers, POI, suspect, witness, hospital reports. It also utilizes login and logout features, gives you the ability to find a user and track which user is currently active. And then here's the code. However, a lot of it has or is marked out just because of the fact that some situations we're struggling on getting them to work properly. But here you can see it calls the instance, and then like it goes through, finds the crime, returns the crime. So, and then also some of these I had been helping with, such as like save the crimes and like to add the crimes. They connect from the facade.
All right, so you guys see the screen?
Yep.
All right, so what I basically did is I did all the people and the crime class. So I started with the base person class, which has a bunch of just starting variables such as name, ID, hair color, all that. A bunch of like methods to get all those variables and change them. And so straight from the person, you get officer, POI, victim, and witness. And usually just have a little bit extra variables on methods that person doesn't have. And then from POI, suspect also extends POI, and then from suspect, criminal extends suspect. By doing this, the inheritance allows for a lot of sharing between the classes. I'll show my code real quick. Like for down here, we have the toString method that returns all the people or the person's information. Here there's the partial compare, which sees if there's a match within like two different people. And suspect extends POI, which extends person. And having them extend each other just makes it easier for being able to do like the super call right here, stuff like that. Make everything a little bit easier. And then for the crime, let me show that. Yeah, so the crime just has a bunch of information such as the type. It has an array list that has everyone involved with it. Just a bunch of methods to get all of that. So, and then there's the evidence over here too.
All right, and I'll go last. I'll try to make it quick. So for my part in the UML, I was in charge of JSON writing and reading. So you get the massive data constants file, which is just a ton of protected strings. These just help with file names and any sort of information in the arrays of JSON information that I have to pull out or write. And then if I can zoom in a little bit, data loader. It comes with a private delimiter. This is used to break up strings into an array that makes it easier to return an object. This was specifically useful in users and hospital report. And then in data writer, you get the methods. Save users, for example, calls upon get user JSON, and it takes each object and converts it to a JSON object, which is then written to the JSON file respectively. So for user, it would be user.json. We can go into the code real quick and take a look at that. Data constants, data loader, and data writer. So as I mentioned previously, it's just a ton of protected strings that help out with file ops. Data writer, so we can actually look at the two user methods that I mentioned. So this one just creates an array list of users, and for each one it goes and calls upon this method and puts them all in the JSON file. And then finally for data loader, we'll go up to the very top and use what's up there. So you can see the delimiter and load people, takes an array list of type person, and creates a person with each instance that appears inside of the JSON object. I believe that's mostly it for our presentation. Is there anything anybody else wants to say? All right, well, thank you.